Hi, and welcome to this video on finding y-intercepts. Okay, in this video we're going to look at graphing some functions, and then we're going to talk about their y-intercepts and how to find them without actually having to graph them. Okay, so the directions tell us that by using transformations or by making a table, it tells us to graph each function, each of the following functions below, and then locate the y-intercept on the graph. Okay, so we're going to do that. So for the first one, we're going to graph the function 3x plus 2. So I'm going to go up. It looks like it's been transformed up 2, and then the new slope is 1, 2, 3, 1. 1, 2, 3, 1. Okay, so we can see that this function has been stretched up vertically. All right, and so this is what the first function will look like. Okay, so we can see that this one is linear, so it's y is equal to x, and we can see that our y-intercept on the graph is the point 0, 2. Okay, so now I'm going to go and graph the next function. Okay, so I can see that this one has shifted. It's shifted to the left 1, 2, and then it's shifted down 1, 2, 3, and it looks like there's no dilations taking place, so this one is the general parent function, but it's just been shifted for the quadratic. So the parent function for this one is y equals x. If you need to graph the parent function before, that's fine, but I don't need to, so I'm going to skip that part. And so I'm going to go up 1, 2, 3, 4. So that's there, and then 1, 2, 3, 4. And I can see that this one looks like the general form of my parabola, or my quadratic equation. Okay, so for this one, I can see that the y-intercept is actually, it looks like it's 0, 1. Okay, and I just get that by looking at the y-axis. So the next function I'm going to graph will be, it looks like it's exponential. So if I were to graph this one, I can actually do the transformation and show you this one, because you guys are probably not used to seeing a parent function of y equals 5 to the x. So what I'm going to do is I'm going to graph, let's see, 5 to the negative 2 would be 1/25. That's going to be really, really small. So I can graph it, but I can't really show that on the graph. So just kind of estimate the best you can. And then 1/5, that one's going to be close to 0. And then 5 to the 0 is going to be 1. And then 5 raised to the first power is 5. And then, of course, 5 raised to the second power will be 25. And so that's going to be off of our graph. So basically, I'll just graph a function that looks like that. Okay, well, I know this one is shifted up 1. So this is the parent function here. This is y equals 5 to the x. So that's the parent function. And then I'm just going to shift this one up 1. So every point I'm going to shift up by 1. Let's see, this one is going to be 1, so 1 and 1/5, and then this will be 1 and 1/25. So this function, when I'm all done, will look like this. Okay, and you can choose to leave the parent function there, but for the purposes of what we're doing today, you really don't need it anymore, so I'm going to go ahead and erase that green function. Okay, so you can use it just to help you graph, but after that, you don't need it. So let me just go over this one so that you guys can see it clearly. I know this orange pen is a little hard to see, but it's my favorite pen, so sorry. Okay, so this function here, I don't need this anymore because I erased the parent function, is the function y equals 5 to the x plus 1. And so we can see that the y-intercept in this case is 0, 2. Okay, so let's graph the last function. It looks like it to be an absolute value function. So we know that the absolute value of the absolute value parent function is a 1-to-1, and it's y equals the absolute value of x. So I know that I'm going to shift it down 5 according to this one. So 1, 2, 3, 4, 5. And then I know that it's going to be doubled in the y direction. So instead of going 1-to-1, I'm going to go up 2 and then 1, so because it's stretched vertically by a factor of 2. And so each time I'm going to go up 2 instead of going up 1. All right, and so this one should look like this. Okay, so even here, we're still looking for the y-intercept, and the y-intercept in this case is 0, -5. Okay, so for all of these, let me zoom out a little bit. We can see that we found the y-intercepts. Okay, so I'm given the same equations at the bottom, or below, so I'm going to scroll down and answer the question. It says, if the y-intercept is where the graph crosses the y-axis, then what is the value of the x-coordinate at the y-intercept? Well, for each of these, I can see that a coordinate is written as a point xy, right? So x is the x-coordinate, so that's the first one. And in all of these, it's the same. What does it seem to be? Well, if you guess 0, that's correct. So 0 seems to be the x-coordinate. Well, give the y-intercept as a point. Well, for each of them, I had 0, comma, some value y. So you can write them all out if you want. Well, we had 0, what was the first one? It was 0, 2, and then 0, 1, and then 0, 2 again, and then 0, negative 5. So if you want to write all those out, you can. 0, 2, 0, 1, 0, 2 again, and then 0, negative 5. Or you could just give a general form, which is 0 and some y value, right? Because it's where it crosses the y-axis. So let's try something different, okay? Let's try plugging the x value in at the y-intercept into each of our functions so that we can find out what the y-intercept is. Because if I plug a 0 in, or we could say the proper word is substitute, right? F of 0 means to substitute 0 in for x. So if I do that here, it would look like 3 times 0 plus 2. Well, f of 0 is going to give me 0 plus 2, which is 2. So I can say that my y-intercept is the point 0, 2. Let's try it for the next one. So I'm going to plug a 0 in again for x. So y is equal to 0 plus 2 squared minus 3. Well, 0 plus 2 is 2, and so 2 squared is 4, so that's going to be 4 minus 3. And so y is equal to 1, and so that will give me the point of 0, 1. Let's try it again. Y equals 5 to the power of 0 plus 1. Well, 5 to the power of 0 is going to be 1 plus 1, right? And so y will end up being 2, so that's going to give me a point 0, 2. Might be onto something here. All right, so then let's try number 8. So y is equal to 2 times the absolute value of 0 minus 5. Well, anything, even if I take the absolute value of 0, it's going to be 0, right? And then if I multiply anything by 0, it's going to be 0, 2. So I'm going to be left with negative 5. So y is equal to negative 5. Therefore, I can write this point as 0, the y-intercept, negative 5. Well, what do I notice about all of these? Well, all of these points that I just found by plugging in 0 are the same as the points, which are the y-intercepts that I found here. So what you should understand from this exercise, okay, so we can say that they are the same. So the values that I found in 5 through 8 are the same as the values that I found in 1 through 4. So what you should understand is that you can substitute 0 in for x for any function to find its y-intercept. Okay, so you can substitute 0 in for x for any function to find its y-intercept. Okay, so you guys are going to get some practice with that on the next page. So you're going to do questions 1 through 10, right? So I'll do the first one with you. So y is equal to negative 3 times 0 plus 6. Well, when I multiply negative 3 times 0, that comes out to be 0. So y is equal to 6. So my y-intercept is 0, 6. Okay? Well, what if I tried for one over here where y is not solved for? Well, I'm still doing the same thing. If I substitute 0 in for x, it's going to be 0 plus y equals 6. So my y-intercept in this case will still be 0, 6. Okay? So it doesn't matter what function you have. It doesn't matter how it's solved for. You can always plug in if you have two variables, an x and a y, and you want to find the y-intercept, you can always plug in 0 for x because the x is 0 where the graph crosses the y-axis. All right, so I hope this video has helped. You can watch it as many times as you need to and go through and work these problems. Okay, so I'm going to end the video here, but you can go through and work these problems and then check your solutions because those are also posted on the web. So make sure you check your solutions because sometimes the y-intercept is not what you would think it would be. Okay, but you have to plug it in order to find out if that's the case. All right, goodbye and see you in the next video.